Lesson 37, adding and subtracting rational expressions. Now, as you see with this very first problem here, whenever it says you have a rational expression, you have some sort of fraction. So we have 7/16 plus 3/10 here. Now, whenever you have a fraction, your first job is to get common denominators. It doesn't matter what the denominator is, it just has to be the same. So remember, one thing you can always do is you can multiply these two denominators together. So if we wanted to, we could take this entire fraction times 10, so we'd have 70 over 160 plus, and then take this thing times 16, so we'd have 48 over 160. So this would end up being 118 over 160. Now, our job was to go from two fractions to one fraction. We did it. All right? Your only thing left to do then is to see if you can simplify. All right, well, first thing I see is we can divide this by 2. So we're down to 59 over 80. And I believe that is as low as it's going to get. So remember, your very last step, doesn't matter what the fraction is to try and simplify. Sometimes you're going to be able to, sometimes you're not. All right, next one. Well, we can do the same thing here. All right, even though there's an x in here, you know, our first job is to get common denominators. Well, let's just multiply these together. So our common denominator would be 45x. For this one, that means that we multiply by 9x. So 9x times 3x would be 27x squared. For our second one, this, we're multiplying it by 5. So we'd have 50 over 45x. Alright, we still have two fractions, but we do now have common denominators, so we can add these two together the best we can with this one. There are no like terms, so we just put them together and put it over 45x. Alright, so we've gone from two fractions to one fraction. That was our game plan for this. Then we need to see if we can simplify it all. Now remember, whenever you have 2 or 3 or multiple terms up on top, put a set of parentheses around it. That means that we can't just cross off this x and this x. And we can't cross off a 5 here and a 5 there. We've got to be able to pull something out of this to be able to simplify with the bottom. Alright, so looking at that, I don't see anything that we can pull out of the top. The only thing we can pull out of a 50 is a 5 and a 10. 5 and 10 don't go into 27, so that's as simplified as the top gets, and because of that, we can't simplify with the bottom at all. So that there is our final answer for this one. Okay, do notice though, our first step was to get common denominators for both of them. Alright, then we got our numerators, we added our numerators together, and then once we got it down to one fraction, we simplified. Or, like over here, we tried to simplify. Okay, the process is the same no matter if it's just two regular numerical fractions or if they have variables in it. So, if we look at this one, it is still the exact same thing. Your first step is to have common denominators. Well, if we look at this, those are already common. So then, we can add or subtract the numerators. So our top becomes 8x minus 24. Our bottom stays x squared plus x minus 12. Now remember, put parentheses around those. And now we have to check and see if we can simplify here. Well, the top, we can pull out an 8. So we're left with x minus 3. The bottom, we can factor this thing. So x squared is x and x. Signs, minus means that the signs are different. So we're gonna have a plus and a minus. And then what multiplies together to give you 12, it adds together to give you 1. That'd be a 4 and a 3. Alright, and now that we factor that, we can see, well, this x minus 3 can simplify with that x minus 3, and we are left with 8 over x plus 4. And that is our answer. Alright, same process, even though it was a binomial on the bottom. Next one, find any values of x for which the following expressions are undefined, and then simplify the expression. Notice the order. It says, figure out which values of x make this undefined first. Well, you've got to do it first whether it says to or not. Because, like on the last one, our x minus 3 canceled out here. Well, here's the thing. If you set this factor equal to 0, we'd solve that x equals 3. If you put a 3 back into this entire thing, we'd have 24 minus 24 is 0. 3 squared is 9, plus 3 is 12, minus 12 is 0. We would end up having a 0 over 0, which means 3 cannot work for this. This would make it undefined. So you have to do it before you simplify here. So coming back here, if we look at this, we have to set the denominator equal to 0. So we've got 4x to the 5th equals 0. Divide by 4, take the 5th root of both sides, we end up with 0. If we do the same thing for the other one, which we have to do, we divide by 12 and take the cubed root, x equals 0. So for this, find any values of x for which the following expressions are undefined. X cannot equal 0 here. Alright, and after a while you're going to be able to just look at this and be able to tell, well, yeah, that's a 0 just based on how it's written. So if we come over here, x cannot equal 0 also, because we just have a binomial here. Or we have a monomial with the x in there. Alright, so if we had a plus or minus in there, it'd be different, but because they're multiplied together, x cannot equal 0 for both of these. Alright, then our job is to figure out what our common denominator is going to be. Well, what we could do is we could take 4 times 12 to get 48, and then x to the 5th times x cubed. Remember, you'd add the exponents, so then we'd have 48x to the 8th. If you do that, there's nothing wrong with that, but if you do that, you're going to have a lot of simplifying to go here. Okay, so instead of doing that every time, break these into parts. 4 and 12. What's the smallest number that both of these go into? That's a 12. 4 goes into 12 3 times, 12 goes in once. Alright, x to the 5th and x cubed. Okay, short, easy way to do it is pick the one with the highest exponent, and that's going to be your common denominator. So our common denominator is 12x to the 5th here. Now, your job is to say, alright, I had 4x to the 5th, I need to change it into 12x to the 5th. 4 times 3 is 12, so I gotta multiply this by 3. X to the 5th turns into an x to the 5th, it doesn't change at all. So for this one, we just multiply by 3. So this would end up being a 9. Plus, and then if we come over here, 12 turns into a 12, that doesn't change. X cubed changes into an x to the 5th, we gotta multiply this by x squared. So this ends up being a 7x squared. Common denominators, add your numerators. Put the denominator down. Is there anything that you can simplify? Well, remember, parentheses, there's nothing you can pull out of the top. So then this is simplified as long as x does not equal 0. For our next one, we already figured out that x does not equal 0. Common denominator, 6 and 7, the smallest number is going to be 42 here. We've got an x squared and an x cubed. Well, that's got to be an x cubed then, because it's the bigger one. Alright, 6x squared has to turn into 42x cubed. Well, 6 times 7 gives us 42. X squared turns into an x cubed, that's going to be an x. So we're going to be multiplying by 7x. Over here, this one, 42x cubed. This, we're going to have to multiply by a 6.
Julie Denton, please come to the
So
office.
this becomes
Julie
a 6
Denton,
here.
please come to the office. Thank you.
So we add our numerators. We write down our common denominator. Remember parentheses. Nothing we can pull out of the top. And then that doesn't simplify with the bottom at all. So there is our answer, as long as x does not equal 0. Alright, one more page. Find any values of x for which the following expressions are undefined, and then simplify the expression. Alright, so we got to set the denominators equal to 0 here. Alright, this looks like it can be factored, so we're going to go x minus 3, x plus 2, which we'll have to do anyways. Okay, if we set this factor equal to 0, well, x would equal 3, so that tells us x cannot equal 3. This one would be a negative 2. When we factor this over here, x plus 4 and x plus 2, set those equal to 0. This would be a negative 4. This would be a negative 2. Well, we already have that, so we don't have to write that again. Alright, now the nice thing about doing it this way is we've already factored the bottom, so we can figure out, well, let's figure out what our common denominator is going to be. Alright, well, we've got 2x plus 2's, so we're going to write down one of those. And then we've got 1x minus 3, that's going to go down. And an x plus 4 is also going to go down. So there's our common denominator. Now for the top here, we have an x minus 3 and an x plus 2. How is this different than this? We need to multiply this thing by x plus 4. X plus 4 times 1 is just an x plus 4. Then we're going to subtract. What's the difference between these two? Well, it doesn't have an x minus 3, so we've got an x minus 3 in there. Alright, so x minus 3 times 1 is x minus 3. Now notice I'm putting these in parentheses because this minus sign has got to be distributed through there. So we've got x plus 4 minus x plus 3 over all of that stuff. When we simplify the top, the x's go away. So then we're left with 7 over x plus 2, x minus 3, and x plus 4. And that is our answer as long as x does not equal 3, negative 2, or negative 4. Alright, so make sure you find these first every single time. Alright, because sometimes they're going to drop out and you cannot do it at the end. Alright, our last one here. Looks like a mess. Alright, the very first thing though is, let me erase this. The very first thing, finding the values that make this undefined. You're just looking at the denominator for each one of these fractions. Well, x minus 1, set that equals 0. X cannot equal 1. X plus 1, x cannot equal negative 1 either. Done. Alright, so then our job is to simplify this down. Well, very first thing we gotta do is this looks like a mess. We've got to simplify this down as much as we can. Forget about the top for now. Forget about that 1. If it just said 1 minus 1 over x minus 1, well, what would you do? You'd get common denominators. You'd have a common denominator of x minus 1. Okay, this one we'd have to multiply by x minus 1. This other one, we wouldn't multiply by anything. What does this turn into? Well, x minus 1 minus 1, that'd be x minus 2 over x minus 1. Now realize with that we've got a 1 on top of it. So I'm going to write this over here, and we'll come back to it later. 1 over x minus 2 over x minus 1. Our other one, we do the exact same thing. Common denominators can be x plus 1. So the bottom becomes x plus 1 over x plus 1 plus 1 over x plus 1. Common denominators are x plus 1. Add the numerators, that'd be an x plus 2 with a 1 on the top of it. So we'd end up with 1 over x plus 2 over x minus 1. Now, if you look at this as a 1 divided by this fraction, can you divide fractions? No, but you can multiply by the reciprocal. So we are going to take 1 times x minus 1 over x minus 2. Same thing over here. 1 times x minus 1 over x plus 2. Alright, and that just ends up being x minus 1 over x minus 2 plus x minus 1 over x plus 2. And then we've got to keep going with this process. So let me write that on our next page here. Alright, your job now, we gotta have common denominators. Well, that means that we're gonna multiply these two together. X minus 2 times x plus 2 for both of them, and I'm gonna write them both out this time. Okay, what do we have to multiply this by to get that? We gotta multiply by an x plus 2. So we've got x minus 1 times x plus 2 plus, how do we change this into that? We're going to multiply at the top by x minus 2. Alright, now normally what I tell you is add your numerators together. Well, we've got to do some work first before we add those. We've got to FOIL these out. So we've got x squared plus 2x minus an x, so plus x minus 2 plus x squared minus 3x plus 2 all over x minus 2 x plus 2. Combine like terms. Now we are at 2x squared minus 2x, and then the 2's cancel out here, over x minus 2, x plus 2, almost done. Alright, now we have to say, well, can we simplify the top here? Well, we can take a 2x out, and we're left with x minus 1 over x minus 2 times x plus 2. And there is our final answer for this one. As long as x does not equal 1 or negative 1 is what we said. Now, if you look at this process though, if you look at this answer, well, it looks like you can have more numbers that would make this undefined. If I put a 2 in here, that's going to give me a 0 on the bottom. So that's going to give me an undefined. Also a negative 2 would also give it as an undefined. So what you have to do for each one of these steps, every time you have a denominator, you have to go back and check, well, is there another number that would make this undefined? And if you look, the 2 and the -2 take care of everything on this page. On the past page, the 1 and the -1 were fine for everything until we divided. Or until we divided the fraction, so we had to multiply by the reciprocal, which then is the 2 and the -2. Alright, so these can be a little bit tricky. Pay attention to your denominators as you go to be able to find your undefined values, and let me know if you have any questions.